Hello wonderful person, this is Anton, and today we're going to be discussing some of the most recent discoveries in regards to the mysterious concept known as population 3 stars, or essentially the first mysterious stars in the universe that most likely served as the foundation for all of the other molecules in the first few millions of years, and eventually produced all of the stars and all of the planets that we have around us. And so today we're going to discuss a very exciting discovery of a never-before-seen galaxy that seems to suggest we may have found them, or at least see signs of something similar to these stars in this particular location. But first, I guess let's start with some of the initial concepts just so that it all makes sense, and just so that you understand how important this discovery is, assuming of course it's confirmed. Now first, we're all familiar with the idea of elements. But in astronomy, elements heavier than hydrogen and helium can only be forged inside stars in a process known as stellar nucleosynthesis. And so here it might help you to kind of stop for a second and consider this fact. Every single element you interact with daily, from the oxygen you breathe to the iron in your blood, had to be created by stars that lived and died billions of years ago. And this is actually something I think about when I'm kind of depressed or sad, and it kind of gets me back into the normal mode. But how exactly did this process start initially? Well, today we believe it all started with these first stars referred to as population 3 stars. The ones that had nothing to work with except for pristine hydrogen and helium produced once the universe cooled down enough following the Big Bang. And according to cosmological models, the early universe was approximately 75% hydrogen and about 25% helium, with maybe trace amounts of lithium and beryllium as well. And the stars that formed from this pure cosmic soup are known as the population 3 stars. This is essentially a classification that we've had for a very long time, with the population 2 stars being a little bit younger and produced following the explosion of these first stars, and the much younger, more advanced population 1 stars, like our Sun, being formed in just the last few billions of years. But for many decades, these stars were entirely hypothetical. They represented the onset of cosmic structure and chemical enrichment, but were practically impossible to find for many different reasons. For example, the distance in this case would be absolutely incredible, because we think these stars existed only in the beginning of the universe, and at the same time they very likely only existed for maybe 2 or 3 million years. And so trying to find the exact moment when they all existed so far has been incredibly difficult. But we now have the telescope designed specifically for this, James Webb. And based on some of the recent observations of this very tiny distant galaxy known as LAP1-B, researchers potentially discovered some of the most compelling candidates yet. With this potential discovery, if confirmed, basically rewriting our understanding of how stars and galaxies form, and teaching us just a little bit more about the universe. But I guess once again, so what exactly is the difference between these stars, and why are population 3 stars so important? Well, here this is in regards to the concept known as metallicity. And in astronomy, this is just a fancy word for the abundance of elements that are not hydrogen and not helium. So for example, the Sun is a star that's high in metallicity because it contains a lot of stuff that's not hydrogen and helium. And that's because the Sun is relatively young and enriched in metals. But older stars, especially population 2, or these hypothetical population 3 stars, are extremely poor in metals, and we actually see a lot of this by looking in the halo of our own galaxy. Some of the stars we've discovered are up to about 12 to 13 billion years old, and for the most part they only contain hydrogen and helium with just a trace amount of elements. You can learn about some of these discoveries in some of the previous videos in the description. But when it comes to population 3 stars, they essentially stand alone. They are the first generation, formed before anything else existed, and before there was anything except for hydrogen and helium. And all of the stuff they formed from has never been recycled or used for anything else. And so because of this lack of metals, or lack of anything more advanced than hydrogen and helium, it would probably affect their structure. But here this is where we basically have to rely on theoretical predictions and assumptions. And some of these early theories suggested that because they couldn't cool effectively, a lot of these population 3 stars must have been behemoths, potentially hundreds if not thousands times the mass of our Sun and tremendously huge in size. But because of this mass, they would also have incredibly short lifespans, maybe 2 to 5 million years maximum. And this would all end with some kind of an ultra-powerful explosion, or maybe a direct collapse into black holes. And so this very rapid demise of many of these stars explains why they are so extremely difficult to find today, because for each individual galaxy we would actually have to find a super tiny time frame when some of these stars potentially existed. And so the only chance to observe them is to look at extremely distant galaxies whose light originated during some of the earliest periods of the universe. And well, LAP1-B is one of these crucial, extremely distant systems discovered extremely recently. And here this is an ultra-faint dwarf galaxy located at a redshift of 6.6, or when the universe was only about 800 million years old. But importantly, because this is a dwarf galaxy, we know that it just started forming, and it's intrinsically extremely faint. As a matter of fact, it would be naturally invisible to us if it wasn't for one little quirk. Here it just so happens to be inside a gravitational lens. You can actually see it in this image. And this gravitational lensing magnified the light from this background object so much that it now appears to be at least 98 times larger. So once again, this is just a super lucky observation. And so here, by using the James Webb and by analyzing the light from this galaxy, in 2 studies you can find in the description, scientists did actually discover something super exciting. Here we had several key pieces of evidence suggesting the presence of these population 3 stars. Okay, so what exactly are they? First, extreme chemical primitiveness. When looking at this galaxy, it seems to be the most chemically primitive star-forming galaxy ever seen. And this is out of hundreds and hundreds seen so far from the James Webb and other telescopes. For example, here its oxygen abundance is less than 1% of the solar value, suggesting that the interstellar gas has been enriched by only a very small number of stellar generations. Or basically this galaxy only experienced a very small number of supernova. Then there's also hard ionizing spectrum. This galaxy exhibits an exceptionally powerful ionizing radiation with something emitting high energy photons. And this type of radiation is inconsistent with your typical metal-enriched stars or population 2 stars or even black holes. But surprisingly is almost a direct confirmation from theoretical predictions for the emissions of population 3 stars. Or just to rephrase this, the very powerful radiation coming from this galaxy seems to be consistent with the models for zero metallicity massive stars. The UV light that they seem to form is almost exactly a match. Likewise, there is an elevated carbon to oxygen ratio that's approximately 1 to 2 times the solar value, despite the extremely low metallicity, and this elevated CO ratio is predicted as a typical chemical signature of population 3 stars. Specifically, it seems to match models where population 3 stars explode as a very faint supernova. And so in these types of scenarios, the initial explosion is kind of weak, preventing the ejection of the inner oxygen-rich layer, which then collapses into a black hole, and the carbon-rich outer layer is expelled, enriching the surrounding gas with carbon. And this is right now the first object ever to consistently agree with the 3 key theoretical predictions proposed by previous studies, with the theoretical modeling suggesting that finding such an object, especially using these highly magnified observations through the gravitational lensing, is statistically expected at this exact redshift. Or just to rephrase this, in terms of statistical probability, this is exactly what we expect to see and when we expect to see it as well. And this object even supports the predictions for the initial mass function, with the emission lines so far being entirely consistent with the presence of these massive population 3 stars, and specifically massive stars formed inside these low-mass clusters. But interestingly, so far the data from JWST shows us that the total stellar mass is surprisingly low, less than 2,700 solar masses in total. As a matter of fact, the calculations based on the observed light suggest that the cluster here contains roughly around 1,000 solar masses of population 3 stars, aligning with the prediction of small clusters and either one or several stars, approximately 1,000 solar masses in total. And by the way, all this was reported in 2 separate studies from 2 separate teams, whose research you can find in the description below. So this is definitely a super exciting discovery, because in this case, 2 separate teams seem to have come to the same conclusion. But here there was still a somewhat interesting point of contention, and specifically in regards to the galactic mass. When analyzing the galactic kinematics, or basically looking at how gas is moving around the galaxy, researchers discovered a very broad hydrogen line, suggesting a very high velocity of dispersion of approximately 58 km per second. And this would suggest something really massive in the center, with a mass of about 10 million solar masses. And so if everything here was driven by gravity, it would suggest the galaxy is embedded in an extremely massive dark matter halo, which would be very difficult to explain, However, this dynamical mass is over 100 times higher than the combined mass of all of the stars in this galaxy, which, as I mentioned, is less than 3,000 solar masses. And even though there might be about 10,000 solar masses of gas, this is still just a little bit too massive based on modern theories. And so this huge gap between observed matter and invisible matter suggests that the system is either extremely dark matter dominated, or is basically inside some kind of a massive chunk of dark matter, or there's something else entirely different going on here, and something that currently does not make sense. Now, obviously, one explanation could be some kind of a central black hole, but no emissions resembling a black hole seem to be visible. But scientists do offer at least one alternative explanation. This very broad hydrogen line might not be due to gravitational orbital motion, but instead some kind of a very fast gas outflow that's actually driven by intense radiation and intense stellar winds coming from these extremely powerful population 3 stars. Or in other words, the fact that we see something moving so fast is not really because it's spinning around something, but because it's leaving the galaxy, with the velocities predicted by simulations once again being consistent with the observed line width, and once again supporting the idea that this galaxy seems to be hosted by theoretically small and somewhat cold atomic halo that seems to have a few of these massive stars inside of it that are driving all of this expansion. And so right now, based on all of the observations, the discovery of this LAP1-B Galaxy seems to align with a lot of theoretical predictions on the population 3 stars and on what we should be finding somewhere out there. And while population 3 stars were traditionally thought to be enormous, some of the new computer simulations have also challenged this idea as well. As a matter of fact, some of these simulations discovered that very strong and very powerful turbulence around these stars seems to develop inside of these molecular halos and produces very turbulent and very violent winds, sometimes up to 5 times higher than the speed of sound inside of this gas. And this massive turbulence efficiently stirs and compresses the gas, causing the primordial star-forming cloud to fragment into multiple clumps. And so in these types of situations, it would most likely produce less massive population 3 stars, anywhere from 1 to 40 solar masses in total, instead of hundreds or thousands of masses. But because this is so super far away, it's going to be very difficult to tell if this is just a few really massive stars, or if it's hundreds of small stars appearing as one. Nevertheless, the properties from this galaxy do actually suggest an evolutionary connection to a population of galaxies we even see today, the ultra-faint dwarf galaxies. Ancient stellar relics that we discovered in the local universe that are mysterious in their own right. And so this galaxy's low mass and extremely low metallicity, dominated by dark matter, and even the elevated carbon-to-oxygen ratio seem to actually match characteristics of some of the nearby UFDs, which implies that this galaxy is possibly something that's going to one day become an UFD. A low-mass galaxy captured when it was still actively forming stars, but that one day is going to become extremely quiet and almost completely lack any stars, becoming dominated by dark matter. And we actually discussed one of such galaxies extremely recently in one of the videos in the description. And so observing this galaxy gives us a rare window into a lot of mysteries of astronomy. Because here we potentially have observations of the first stars, but also mysterious galaxies we discovered not so far away from us. And so assuming this is confirmed in the next few months, this is going to be a landmark achievement. Mostly because it provides spectral evidence for the existence of these first stars, and officially proves the existence of these zero metallicity stellar populations that were predicted by various models. But naturally, this was not an accidental discovery. Obviously, the gravitational lens was accidental, but the James Webb was specifically designed to find these stars. It was actually one of its primary missions. And so finding these primordial systems was exactly what James Webb was made for. And this is a really important study for cosmology. It essentially provides us with a very important link between the post-Big Bang universe, with basically no stars and just a lot of primordial matter, and the chemically enriched cosmos we inhabit today. But we still need to hear about what other scientists think and wait until additional explanations or possibly counter-propositions on what exactly this is. Anyway, we'll definitely come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also buy the Wonderful Person t-shirt that features James Webb in one of the links in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.